After 7 episodes of C programming, we are finally in a stage where we can finish off building this analog clock here. Last episode, we left it off in this state where all the images are rendered, but they are rendered in the upper left-hand corner of the screen coordinate system. That means the upper left corner of each image is mapped to the origin. In order to change that, we somehow need a way to move individual images to a specific position inside of our screen coordinate system. The way to do that is to use a translation matrix. This matrix is essentially an identity matrix with ones across the diagonal and the offsets in X and Y in the last components of the first 2 rows. Multiplying our input with the translation matrix results in a new vector which is moved by the offset in X and Y. Once we figure out the offset for the minute hand, the hour hand and the knob, we get this result. In code, that means we need a new header file for math operations, and in there we are going to define a free function which just returns a new translation matrix. So this one gets an X and Y offset as input, and now we are going to define the 4 rows of the matrix with ones along the diagonal, and then just return the whole thing. For convenience, I also implement a function which returns an identity matrix. That just means we pass in 0 to the translation matrix function and return this. Next, we are going to add a matrix to each image. So each image gets a model data struct containing a so-called model matrix. And in our load function of the clock app, we now restructure things a little bit and create a new model data structure for each of the images. Now we need to figure out the X and Y offsets for each image. For the background, there is no offset, so we can use the identity matrix. And for the other 3, we need to calculate this a little bit. So first I will get the center in X and Y from our background. To make this a little bit more readable, I grab out the dimensions of all the images, so the hour hand, minute hand, and the little knob, and then assign all the model data structures to the individual images. The offset of the hour hand is half of its width of the center, and for the Y, the offset is the center Y minus the height of the hour hand. Same applies to the minute hand, and the knob needs to be positioned half of its width of the center and half of its width from the Y coordinate. Since the transformation of our geometry happens in the vertex shader, we now need to pass the model data over to the shader, and that's happening again via a buffer. In the vertex shader itself, we just multiply the model matrix by the incoming position and transform our geometry that way. The renderer now needs a new array for our model buffers, and in the rendering function we just set this new buffer at index 2. Index 1 is already the uniform buffer. Grab this out of our array, and then it should already work. Of course, it doesn't work, and the reason is that we have not yet created the actual buffer and inserted it into the array. So that's what we are doing now. Create a new model buffer with the size of the model data, copy the model data in it, and then insert this model buffer into the array of model buffers. This now finally does the trick, so now the knob and the minute and the hour hand are in the correct position. The 2 hands are a little too high, so that's why I'm going into the app again and decrease the height by a fixed amount of 15 in this case, and double check again that our minute and hour hands are in the right spot. Rendering-wise, this leaves us with a last task, that is to rotate the minute and the hour hand according to the actual time. Rotating objects in our system always means we are rotating around the origin of our coordinate system. But what we want is we want to rotate the images around a certain pivot point. Luckily, we already know how to move objects in our scene, so now we again use a translation matrix to transform our image from the position it's in to the place where the pivot point lies on the origin of the coordinate system. The actual rotation is achieved by using a rotation matrix. So we pass an angle in radians, and our whole geometry is rotated around the origin by the specified angle. Last but not least, we transform, again using a translation matrix, the hour and the minute hand to their final position. In code, that means that we need to add another matrix to our model data, this time the pivot matrix, and also the rotation angle. To begin with, I initialize the pivot matrix for each image with the identity, which shouldn't change anything. And in the shader, I now go ahead and use the pivot matrix to transform the incoming geometry points to the pivot point, and then afterwards using the model matrix back to the final position. Building and running this shouldn't change a thing, so we should still get the same result. And now we can change the pivot point for the hour and the minute hand. For the hour hand, that's half its width in the negative x direction, and the height we just calculated earlier, again from the origin. Same applies to the minute hand. Now that we have changed the position of the minute and hour hand to the pivot point, the translation to their final position changes a little, so we just need to offset them using the center x and center y. The final piece in our shader is now the rotation matrix itself. So for this, I'm just creating a 2x2 matrix, since the third and fourth dimension are not needed here. And I grabbed the rotation out of the model data we got back from the CPU side and used the rotation matrix to rotate the image, which is now at the pivot point. And after that, it gets translated by the model matrix to the final position. So here we have a couple of typos, and it's not working. And the reason is we had a typo in our rotation matrix as well. So now everything's fine, and nothing has changed because the rotation angle is still 0. In order to test if our rendering pipeline works correctly using the rotation and pivot point matrices, I quickly set the rotation to 20 degrees clockwise, and I need a new function to calculate from degrees to radians here. So that's what I do. I need pi divided by 180 gives radians per degree, multiplied by degrees gives the radians. Now we should see that the minute hand rotates 20 degrees clockwise, which is the case. As of now, we have just created a single state of our clock app in the load clock app function and then just rendered this state to the screen. What we now want is to update the hour and the minute hand whenever we are called from the render loop. So for that, I now change the rotation. And since we don't have any means to update the buffers in our renderer, we need to extend our platform services API to exactly do that. So I go ahead and implement a platform update image function. And this function has to do one thing and one thing only. It copies over the model data information from the image to the buffer we have in our renderer. Using this API allows us now to change the rotation angle of the hour and the minute hand every single frame. As before, I want to validate that the whole thing works, so I go ahead and create a static angle variable and count the angle up and expect to see animating hour and minute hands with the next state, which is also working. Now that our renderer can update rotations and translations in real time, we now can go ahead and grab the time from the system by using a C header. So we grab the local time information and get hours and minutes. The hours are in 24-hour format, so we need to convert this to 12 hours for our analog clock. The hour angle is 180 degrees divided by 6, because it's like half circle. And for the minutes, it's 180 divided by 30, multiplied by the minutes. And this should already give a decent result, not entirely correct, since the hour needs to be closer to 1 o'clock. And with adding the minutes per hour to the hour angle, we are done and have finished the small project building this analog clock. In the next episode, I'm going to demonstrate how to use instance rendering to do the highlights of these hour ticks. And yeah, that's all. Until then, have a good one.